Hi there, in this video I'm going to machine the cylinder heads for the Howell V-twin. Now the cylinder heads are made out of aluminium, so first of all I'm going to square up some of this stock. Now there are a lot of videos out there showing you how to square up stock, so I won't go through all that process. After I've got it down to size, I'll get back to you. So the cylinder heads are 2.25 inches by 2.25 inches and they're an inch deep. And I've roughly marked up the areas I need to start machining from the top view. And all the measurements are based upon the centre point. And if we look at the diagram here, these two holes here, there and there, are going to be to hold the rocker fulcrum posts, and these holes here are the holes to bolt it to the cylinder, and these holes here are for the valves, or the valve guides, and that hole there is for the spark plug, and the spark plug is angled, I think at 30 degrees, so that will go like that. So the actual dimensions I'll machine accurately based upon the DRO on the milling machine, but like I say, these are just a guide to help me sort of double check that I'm not making any silly mistakes. So first of all, to find the centre of the part, well, that looks pretty good. Now I've set this stop here, and with both parts being identical in terms of dimension, it means that now I've got this on centre, I can just slot the other part in here and that'll be on centre as well, so that saves a lot of messing around in future. So I've decided to do all my centre drilling in one go, and the location for the centre of one of the holes for the valve guides is 250 thou offset from the centre on the y-axis and 100 thou offset from the centre on the x-axis. So I'm just going to go around all the locations and do the centre drilling, but I'll do all that off camera. Now when I marked up the holes that are used to hold the cylinder head down, I used a bit of trick to work out the x and y coordinates, because it's a bolt circle function that you use on the DRO, and good job I'm using the DRO here, because I've calculated these positions incorrectly. So to just go through this, for the bolt circle function, XY, centre location, diameter 1.35 of an inch, starting angle 45 degrees, ending angle I always add 360 to it, so that gives 405, and I add 1 to the number of holes that I want, because the first and last holes will be the same location, and that comes up with the correct coordinates. So I shall drill the holes based upon these coordinates. But like I say, I'll do that off camera. Okay, so that's all the centre drilling done on the top side. And now what I need to do on the bolt circle holes is to drill through with a number 28 drill bit. Now I've not got one of those, but I've got a 9/64, which is just a couple of thou over. So I need to go through all four with this 9/64 drill. Okay, so I'll just repeat the exact same process on the other three holes, but I'll do that off camera. Now I need to counterbore 0.62 of an inch deep using this 1/4 of an inch 2-flute end mill. So for the holes for the rocker arm fulcrum posts, the drawing suggests drilling through with the number 33 drill bit, but I've not got one of those. I've got number 32. I don't think it's that important, but 32 is probably 3 thou bigger, and I think it's just for a clearance of a bolt. So I'll go straight through with this. And again, these need to be counterbored with a 1/4 inch 2-flute end mill, and these need to go to a depth of 0.75 of an inch, so getting even deeper. I had to nibble away at that because these flutes aren't that long. Well, everything seems to be going to plan at the moment, so what I need to do now is to drill and ream these holes here. These are for the valve guides, so I'm going to ream them to 13/32 of an inch in those places. I don't know whether I've shown this before, but I got these charts from, I think, CPC in the UK. Could be wrong. Fantastic. I mean, those are all about tapping and clearance drill sizes, but this one here, absolutely superb for converting metric to imperial, and it's got all the drill sizes there. Highly recommend one of those. So this is a 25/64 drill bit. Now, when I made the Hogler engine, I made this fixture which enabled me to hold the cylinder head and machine the hole for the spark plug. So what I've decided to do is follow the same sort of principle. So I've modified the fixture and put these bars in here, which will enable me to fit the cylinder head on. The idea is you bolt it, and then you can put it in the vise and do the machining. So the spark plug hole needs to be sort of drilled 30 degrees from that plane there. So if I measure that angle there, that should be 60 degrees. That's pretty close to 0. Just slightly over. So I'm pretty happy with that. And I've used an edge finder on both edges to find the centre. I've just used this wiggler just to check that I'm spot on the line that I marked. And I think we're good to go. So what I'll do first of all is I think I'll use a 2-flute end mill just to open that up, so I can do a centre drill and then drill through with a 6mm and then a 9mm drill bit. Okay, so that allows me to use a centre drill, then I'll drill through with a 6mm drill bit, and then I'll get back to you. Now I've just had to use a 2-slot end mill here, 14mm one, just to open this up before I could drill through with this 9mm drill bit. And when this goes through, it's going to be ever so close to the edges of these holes at the bottom end. Fingers crossed I've got my calculations right. I'll just have to continue with the camera off because I can't get access with the camera in this position. Well, the 9mm drill bit seemed to go through okay, but I've come across a bit of a problem now, because there's a suggestion that you use a 3/4 of an inch 2-flute end mill to drill down a certain length. And it gives you the length to drill down from once this cutter's started to cut a circle. But the problem is, my socket for this spark plug is wider than that. So it's just over 20mm, and all I've got is a 22mm 2-flute end mill. So I think what I'm going to have to do is drill down using the 3/4 inch one until I just cut a full circle, and then I'll be able to work out how far to cut down with the 22mm one from where that full circle is, if you get my drift. I'll get back to you once I'm ready to cut with a 22mm. Well, I've done a bit of umming and ahhing on this one. So I've still got the 3/4 inch 2-flute end mill in here, and I cut to a depth where it's just created a circle on all faces. And the instructions say once you get to that point, you should go down by another 0.54 of an inch. So I'm going to do that with this 3/4 2-flute end mill. I know it's not wide enough, but at least it'll get me to the correct depth, and then I can make a judgment call on it. Well, that's 0.2, not 0.54. Because I'm just going to check a measurement. Okay, so I'm just checking that if I go down to 0.54 of an inch, just to see how far down it goes. So I'm guessing that'll be okay, because beyond that it'll be tapped for the spark plug. So I think I'm okay with this 3/4 one to that depth. I think any bigger it's going to be a problem, but maybe I can open the top bit up a little bit more. Yeah, I think that's the plan, so I'll carry on. Okay, let's continue to 0.54 of an inch. Not quite there, but this camera's in the way again. I'll get back to you once I've got to that depth. Well, I've decided I'm going to tap it, and then I can see where we are with this opening, see what we can do with it. This is an M10B1. Okay, so time for a quick sanity check, and I've machined this exactly to spec. So that is 3/4 of an inch in diameter, and as you can see, none of my sockets will fit in there, and you know, they're not exactly thick walls on these sockets. So I'm going to open this up to probably what was it, 13/16 of an inch, which will just give me enough clearance. And if I go to a depth where I can just get the socket onto the hex sort of nut area, I think that'll suffice. So that hex nut area from that position there is to the top of it is 140 thou, and the actual hex nut is 120 thou thick. So if from this position I go another 260 thou with this 13/16 of an inch 2-flute end mill, that hopefully will give me the clearance I'm after. So the really big advantage of using this jig is you can actually take the piece off, machine the other one. If you've got a problem, put it back on, and as long as your DRO's in the 0 position, everything's good. So what I need to do then is to, with this 13/16 bit, is to get down to that level there. Once I get there, I need to go another 260 thou. $260. So I can take this off and I can check the spark plug again. I think I've got a result there. I just managed to get these sockets in. Happy with that. Only slight issue, not major issue, it's just broken through here on the other side. There's going to be some fins cut here anyway, so it shouldn't be a big deal. And now we've got two. I've just been checking the clearance of where the spark plug comes, and it's around about 20 thou. So the spark plug is 20 thou less than this surface, which I think will be okay. And what I need to do now is cut out some recesses for the intake and exhaust ports. I can't actually drill the ports at the moment until I get the valve guides in place, but I can sort of cut out the recesses. So the recess for the intake and exhaust ports is 93 thou deep, and it's centred on the holes that are going to take the valve guides. Now the width of this needs to be 1.15 of an inch, and I'm using a 20mm cutter. So that means that I need to move the x-axis this way, a total of 0.1813 to actually get to the edge that I'm looking for. I'll do it in increments, but I'll still keep it at 93 thou deep. Now the recesses for the exhaust are very, very similar to the intake, the only difference being the width. So again, I'll do that off camera. Well, the cutting of the recesses worked out okay, and then I thought I'd just do a bit of drilling and tapping, and but unfortunately broken a tap. It's only the second time I've ever broken a tap, but I'm not going to panic at the moment. There is scope to re-drill another hole there and modify the part that attaches to this piece, but I need to think about that. But anyway, I'm going to press on. And I think the next stage is to start cutting the fins. So I'm just testing a method to cut these fins. And I've got an 1/8 of an inch 2-flute end mill here. I'm plunge cutting right along, and then I'm gradually sort of cutting downwards in about 100 thou increments. So once I've gone right along doing that, I'm just turning the dial 2 revolutions here on the y-axis, going down. Once I've done that, I'll go back and join the like dots up. I'm fairly limited to a depth of 400 thou. I should be going a little bit further than that based on the drawing. But anyway, now I'm going to join these holes up. So having joined the holes up, I'm now cutting crossways in 100 thou increments. Well, the example on the right was produced by the 2-flute 1/8 of an inch end mill. So a plunge cut and then cutting across, and that's pretty rough really. I'm not overly happy with that result. The one on the left, I took a slightly different approach. I used a 3mm 2-flute end mill for plunge cutting, and then I ran across it with an 1/8 of an inch end mill. Slightly better result, not as rough on the edges, but certainly not perfect. And the drawback with the left one is with the 3mm I could only go to a depth of 0.3 of an inch, as opposed to with the 1/8 of an inch 2-flute end mill I managed to go to a depth of 0.4 of an inch. The drawing suggests 0.45, but I might just get away with that. The other option is to use a slitting saw. That's one hell of a slitting saw, isn't it? That wide. But I might have to buy one and give it a try. So more experimentation needed. Well, the slitting saw has arrived from Archeoro Trade. and there it is. It's a 3 inch in diameter, 1/8 of an inch thick, and 28 teeth. And I've just given it a try on these 3 cuts really, and that's a far better result. So I'll go back to the mill and start cutting the fins on the cylinder heads. So I place the cutter on the centre line, and then I move the cutter up by 0.0975 of an inch. And now I'm going to cut in 40 thou increments until I get to a depth of 450 thou. Well, that's one cut made, 450 thou deep. So what I need to do now is to move the cutter up by 0.195 of an inch, then repeat again, exactly the same cut, up again by 0.195, cut again until I've completed the top. Once I've done that, I'll switch it round and repeat exactly the same process, but I'll do all that off camera. And the last cut. Well, they seem to turn out very well. I'm really impressed with that slitting saw. Got a really good consistent result. And off camera I just did a bit of counterboring here. Those to hold the rocker posts. So yeah, happy with that. Only problem is that broken tap there. But hey ho. Well, things are looking up weather-wise, which is good news, and I just can't believe I broke the tap. It's only the second time I've broken a tap. The problem with this one is it's quite small, and I came across a company on the internet that make really good tap extractors. They've got some long fingers on them, but unfortunately the smallest they go to is 3mm, and this tap is around about 2.2mm in diameter. So I think what I'm going to try and do is order a cheap and cheerful one off eBay. They've only got sort of like very small fingers on them, and I think that might be designed for the 3mm tap as well. But I'll try heating the part up and try using that extractor, and if that don't work, I think I'm just going to have to re-drill somewhere else on the head and modify the part accordingly. Apart from that, I'm really happy with the way they've turned out. So I hope you enjoyed the video, and I hope to see you later.